We often treat innovation as a series of lucky eureka moments, but in reality, solving complex problems is a repeatable architectural discipline. Take a physical contradiction you've likely dealt with at the dinner table, trying to get a thick, heavy liquid out of a nearly empty container. When the contents refuse to move, we default to brute force. We shake the bottle, we squeeze the sides, or we hammer the base with the palm of our hands. The frustration is built into the design. To get the product out, it has to travel all the way to this opening at the very top of the structure. Engineers frequently accept these flawed orientations because that's simply how the product has always been made. If you want to move past the trial and error trap and see how systems are actually built, consider subscribing to the channel, ring the notification bell, and leave a comment about the manufacturing or design hurdles you'd like to see us take apart next. Brute force is a sign that the engineering has failed to account for basic physics. To fix it, we need a systematic approach. The systematic antidote is TRIZ Principle 13, the other way round, or intentional inversion. Usually, engineers try to fix a dispensing bottleneck with more complexity. They might design expensive squeeze pumps or add chemical non-stick coatings to the interior walls. This chart shows the real contradiction: the high viscosity liquid at the bottom versus the exit point at the top. Here, gravity is the enemy. It constantly pulls the product away from the opening, forcing the user to fight physics for a single serving. The friction isn't a problem with the material. It's a problem with an architecture that refuses to work with natural forces. TRIZ Principle 13 starts with a simple question. What if we did the exact opposite of the conventional approach? Instead of adding pumps, we invert the entire structure, placing the opening at the bottom. This moves the liquid's resting position directly against the dispensing end. By flipping the design, gravity becomes the primary force pushing the liquid out. For the user, the change is immediate. There's no more shaking or hitting the container because the liquid is already where it needs to be. While this requires new designs for valves to prevent leaks under the constant pressure, inverting the orientation allows engineers to bypass flow barriers that used to require human brute force. This inversion strategy changed the standard for how thick liquids are packaged across a variety of industries. You can see the same logic in the personal care industry, where shampoo and conditioner bottles were redesigned to stay inverted, ensuring the product is ready to dispense the moment it's opened. This stands in stark contrast to the rigid manufacturing lines of the past, where the orientation of the product was rarely questioned. Look at the products or assembly sequences you manage. Where are you or your users currently fighting a losing battle against tradition? Try applying Principle 13. Turning a bottleneck upside down is often the fastest way to eliminate friction. Engineering a frustration-free experience is a repeatable skill. It just requires the willingness to look at the problem from the opposite direction.